Page 2 of quadratics for math studies. Let's see, here's a little review here, things that we discovered in our investigation. If A is positive, then the graph is shaped like a U. And if A is negative, then the graph is shaped like a hill. The curve intersects the y-axis at 0, c. We discovered that, right? And when they say c here, they're talking about standard form ax squared plus bx plus c. This c here is the y-intercept. The equation of the axis symmetry is x equals negative b over 2a. Okay, now this is a way of finding the axis of symmetry using the coefficients or the numbers that are in the standard form, right? And we can practice that a little bit here, although sometimes we won't have to do that, okay? And the x-coordinate of the vertex can also be found by using x equals negative b over 2a. If you remember in the investigation, you derived x equals negative b over 2a because you found a rule in which when you make b a certain value, you discovered that the x-coordinate of the vertex could be found by taking the negative of the b value and then dividing the b value by 2, or dividing it by 6, or by dividing it by 10. And the way you decided whether you would divide it by 2 or divide by 6 or divide by 10 is based on the a value. So that is exactly what this is doing, right? If you look at this, if the a value is 1, the rule is the negative of b and you divide it by 2, right? If a is 1. If a is 3, then it will be negative b divided by 6. Do you remember that rule? You also created that rule, right? So you can actually use this rule, negative b over 2a, which automatically modifies itself depending on the value of a. So we're going to work on this. Even if you don't understand what I just said, that's okay. We're going to practice a little bit on this page. So for these parabolas right here, for these quadratics, we are going to do 3 things. One is we're going to find the equation of the axis of symmetry. And we're going to do that using the equation x equals negative b over 2a. And sometimes we are also going to do it by looking at the calculator. Okay? The other thing we're going to do is we're going to find the coordinates of the points at which the curve intersects the x-axis, known as the X-Intercepts. Okay? And the other thing we're going to do is find the coordinates of the vertex. Okay? So let's look at the first one. And of course, whenever they give us any equation in math studies, we want to first input it into y. I open up the y equals screen, and then I'm going to type in x squared minus 2x plus 3, because that's the first example. X squared plus, or no, minus 2x plus 3. Okay? And I'm going to graph it. And thank goodness in math studies, usually the standard grid is fine for us, and we can see it there. And there's a couple things we want to know. We want to know the equation of the axis symmetry. We want to know the points where the curve intersects the x-axis, and we want to know the coordinates of the vertex. Well, looking at the graph, I can already tell you that the curve does not intersect the x-axis, right? So we know that the answer for B is nothing, okay? The coordinates of the vertex. So there's a couple ways we can do that. First, we're going to do the calculator method, okay? So we're going to do second calc minimum, because that happens to find us the vertex, right? So let's do that. Second calc minimum. Okay, and then we're going to mark the left side, we're going to mark the right side of the vertex, and then we're going to do a guess where it doesn't really matter where the guess is. So we'll go to the right side now, hit enter. And then it asks us to do a guess. It doesn't matter where the guess is because there's only one minimum here anyway. It only matters where the guess is if there's like, you know, like a W shape and there's 2 minimums and you want to get close to one of the minimums, okay? So the answer is 1.000012, y equals 2, but we know from math studies that 1.000012 is actually just x equals 1 and y equals 2. So the vertex happens to be 1, 2, right? And what would be the axis of symmetry? Well, the axis of symmetry is the x-coordinate of the vertex, so it would be x equals 1. Okay, so I will also want to show you how you could find the axis of symmetry using x equals negative b over 2a. Okay, so let's mark what are b and c and a looking at this equation. So b would be negative 2, c would be positive 3, and a would be, there's no a there, right? But when there's nothing there, it actually means a equals 1. Okay, so let's try to figure out the axis of symmetry by using x equals negative b over 2a. We already know that the answer is 1, but later we're going to show you certain types of problems the IB is going to give you where you cannot use the calculator to solve it, and you will need to use negative b over 2a. So we need to know how this works too. So we'll put negative, and we know that the b value is negative 2. When you put the b value here, make sure you put the negative sign there also, because that's part of b. And then a is 1, so it would be 2 times 1. And if we simplify this, negative negative 2 is equal to positive 2, and the bottom is just equal to 2. So in the end, 2 divided by 2 is just 1. So our axis of symmetry is x equals 1, because if we substitute in the b and the a value into negative b over 2a, we also get 1. So we have two ways of finding it, right? One is we use second calc min to find the vertex in this case, and then we just take the x coordinate, and that is also the axis of symmetry value, right? Or we could use x equals negative b over 2a. Let's say that you did not use the calculator to find the vertex, and you want to find the y value of the vertex, which happens to be 2, by using the axis symmetry value 1. So one of the things you could do is you could go to the y equals screen. Oops. Let me go to the y equals screen, and you type into your function again, and then you go to your table, and then you're going to say, okay, I know that the x value of the vertex is 1. So if I find the x equals 1 position in the table, I know that the y value that corresponds to it, y equals 2, is also the y value of the vertex. So that's a way of finding the vertex also. Okay? All right, let's go to number 2. I'm going to type number 2 into the calculator. So it's equal to x squared plus 4x minus 5. X squared plus 4x minus 5. Now I'm going to graph it just for fun. Okay. Ooh, the vertex is way down here. Let's find the vertex. How do we find the vertex? Well, since this is a minimum vertex, since it opens up, we're going to do second calc minimum. And then we're going to move the left bound. We're going to move the arrow to the left side of the vertex. We're going to hit enter. We're going to put the cursor on the right side of the vertex, and we're going to hit enter again. And then the guess can be anywhere, but we'll just hit enter. And we can see that the answer is negative 2.00001, negative 9. But we know that negative 2.00001 is the calculator's way of saying negative 2.00. So it's negative 2, comma, negative 9. So the vertex here is negative 2, comma, negative 9. If we know that the vertex has an x-coordinate of negative 2, we know that the axis of symmetry is x equals negative 2. Now, do we have to write x equals? Yes, we do, because the axis of symmetry is actually a vertical line, and the equation of a vertical line is x equals negative 2. Negative 2 by itself does not represent a vertical line. Only if you write x equals negative 2 does it represent a vertical line. Okay, second of all, do we intersect the x-axis in this case? Yes, we do. We can see from the graph that we intersect the x-axis. So how do we find these points where it intersects the x-axis? Well, there's a couple ways to do that. One way, which doesn't always work, is second table, and you look around for when y equals 0. I see one there, right? I see y equals 0 right there. Is there any other place where y equals 0? Oh, there's one there too. Why doesn't that always work? Because sometimes it does not exactly cross when x is a whole number. Okay, so I'm going to show you a way that's a little bit better because it'll always show you where the x-intercepts are no matter what. So the way you do that is you look at the graph and you say, okay, I see it intersects here and it intersects here. Where are those points exactly? So you're going to do second calc 0. Second calc 0 finds when y equals 0. Second calc 0. And 0 is option 2 here, right? So when I do second calc 0, again, it's going to ask for a left boundary, a right boundary. So I'm going to try to find this one first. So the left boundary, first I'm going to move the cursor slightly to the left of that, and I'm going to hit enter. Then I'm going to move slightly to the right, and then I'm going to hit enter again. Do you see when I go to the left and right, I use the left and right arrows? Even though I'm using left and right arrows, sometimes it goes up and down because the function itself goes up and down, right? And then it asks me for a guess. Again, in this small interval here, this is the only place where it crosses the x-axis, so it doesn't really matter what my guess is. So I'm going to go ahead and hit it, and it gives me the answer, x equals -5, y equals 0. So it's -5, 0. Okay? So the coordinate is going to be, it's going to be -5, 0 for one of the x-intercepts. And the other x-intercepts right here, let's go find that. We unfortunately have to repeat the whole procedure again. Second calc 0, left bound. Let's put the cursor like around there, hit enter. We go slightly to the right, hit enter. Guess, doesn't matter where. 1, 0 is the other x-intercept. Okay, so there were two x-intercepts. One was -5, 0. The other one was 1, 0. Let's do number 3. So number 3, and I think that you probably got the hang of it now. So you could go ahead and stop the video and do a few problems on your own and just check the video to see if you got the right answer. How about that? So go ahead and stop the video if you're pretty sure of yourself. Okay, if you're not, you can continue here and watch. So x squared plus 6x plus 4. So again, we can graph it just for fun. But actually, we want to find the vertex, right? We want to find the axis symmetry. We want to find the x-intercepts. In the end, asking for the axis symmetry a lot of times basically means that they want you to find the vertex. But remember, they're going to give you some problems later, and you don't know how yet. But sometimes they're going to give you problems where you cannot use the calculator to figure out where the vertex is. So I'm going to show you one more time to show how to find the axis symmetry using x equals -b over 2a. Okay, so what am I going to do? I'm going to find the b value, which is +6, and I'm going to find the a value, which is, it's missing, but that means it's a equals 1, right? So it'll be -6 over 2 times 1, which means -6 divided by 2, which is equal to -3. So our axis symmetry is equal to x equals -3. Okay, and if I wanted to find the y value that corresponds to x equals -3, I could find that by putting the equation into the calculator and going into the table. I can see that x equals -3 corresponds to y equals -5, right? So -3, -5 is the vertex. Let's find the x-intercepts. Again, you could find the x-intercepts by looking for when the y value is 0, but as you can see, we can't see that in this particular case because it happens to cross the x-axis at points that are not exactly whole numbers. So this point and this point are not exactly whole numbers. So let's try to find it using second calc 0. So we're going to find this one first. So we're going to put the left boundary way to the left on the left side of that crossing point. That's good. And we'll hit enter. And then we'll put the right boundary slightly to the right of that crossing point and hit enter. And then we'll hit the guess. And that'll give us, that's a pretty weird number, -5.24. Why do I put 5.24 instead of 5.23? Do you see how it's 5.236? Well, 6 is slightly above 5. 5 is our dividing point for when we round up or round down, right? So -5.236 is going to be -5.24. So I'm going to write -5.24, 0 as one of the x-intercepts. -5.24, 0, right? We're always going to put 3 significant figures, right? Don't put -5.2 because that answer is definitely going to be wrong. Let's do second calc 0 again, because when you're finding 2 x-intercepts, you need to repeat the procedure twice. Left bound is the left bound means the left marker slightly to the left of this point, and then we'll hit enter. And then we go slightly to the right of the point and we hit enter. And then the guess again can be anything that's close to this point. Do you see how there's 2 x-intercepts now? So now it's slightly important to do a good guess, but we're already in the right neighborhood, so it doesn't really matter. So this x-intercept is -0.764, right? So -7.64, 0. Okay, and you see how we rounded up here because 7, 6, 3, 9, the 9 rounds the 3 up to a 4. Okay, let's do number 4. So number 4, we're just going to, again, they gave us an equation, and in math studies, if they ever give you an equation, the first thing you're going to do is you're going to type it into y equals. The only way they can force you to do algebra is if they give you an equation where they put variables in for the numbers instead of just numbers. Okay. And when I say variables, I don't mean in for x, because x you're always going to have. But if they give you something with k's in it or something, that can force you to do algebra. Those are the hardest kind of problems in math studies. So let's graph it just for fun. Okay, and there's our vertex right there. Let's find the vertex by doing second calc min. And let's first mark slightly to the left, then we mark slightly to the right, and then we hit enter for guess, and it gives us 0.999999 negative 1. And so we know that 0.99999 is actually 1, right? And y is negative 1. So our vertex is 1, negative 1. So what is our axis of symmetry? It's always the x value from the vertex, so it's x equals 1. Okay, now let's try to find the x-intercepts. So if you would like to zoom in a little bit, you could adjust the window so that maybe like instead of going from negative 10 x min, 10 x max, maybe we could put it on like negative 3 to 3 or something. That would zoom it in a little bit. Let's graph that. Okay, that's a little bit better. Now we're going to try and find this x-intercept and this x-intercept, and we do that using second calc 0. So we move the cursor slightly to the left of this first intersection point, and it's already there, so we just hit enter. Then we move it slightly to the right of the intersection point, and we hit enter again. And then we take a guess, which can be anywhere that's close to this, and look, it found us the x-intercept. It's at 0.423. 0.423, comma 0. That is not a good 0, comma 0. Okay, and now we're going to find this other point here, and we're going to do that by repeating second calc 0 again. So we put the left boundary here, and then we move the right boundary slightly to the right of the intersection point, and then we guess, and we get 1.58. Oops, 1.58, comma 0. Okay. Last of all, let's show how to find the axis of symmetry using the formula x equals negative b over 2a. So x equals negative b over 2a. The b value here is negative 6, and the a value here is positive 3. So let's plug those in. So we'll have negative 6 divided by 2 times a, which is 2 times 3. So we end up with negative is positive, so positive 6 divided by 2 times 3, which is also 6, so that happens to be equal to 1. And hey, look, that's exactly the answer that we should have gotten, okay? All right, let's go down to number 5. Number 5. So let's type in our equation, which is 2x squared minus 8x minus 1. And then we're going to first check the axis of symmetry and the vertex. And the way we do that is we just graph it. Oh, I forgot to adjust my graph. Let's make the zoom go back to the regular zoom. The regular zoom is called zoom standard. So we just go down to option, where is it? Oh, there it is, option 6. Okay, let's find the vertex by doing second calc minimum. Left bound, enter. Right bound, enter. Guess. So 1.999 is the same thing as 2, so it's actually 2 comma, is that negative 9? I can't really see. 2 comma negative 9, I think is what it says. That's the vertex, I think. Okay, we can check to see if it's really 2, negative 9 by looking at the table. Let's check. 2, yeah, it is 2, negative 9. Okay, so if the vertex is 2, negative 9, what's the axis of symmetry? Well, the axis of symmetry is the x value of the vertex, of course, so it's x equals 2. Then we want to find the x-intercepts of this graph. Okay, so we want to find this point and this point, so let's use second calc 0. So we move the cursor slightly to the left of the first intersection point that we want to find. We hit enter. We move it slightly to the right. We hit enter. And we do a guess, which doesn't really matter where it's at. And our value is negative 0.121, comma 0. Negative 0.121, comma 0 is the first intersection point. Let's find the second intersection point, which is the right one. Second calc 0. And we'll put the left bound slightly to the left of this point here. We hit enter. We move the cursor slightly to the right and hit enter, and then we guess. So we have 4.12 for the x coordinate, and the y coordinate is, do you see how it says negative 1 times 10 to the negative 12? That's the same thing as 0.00000, 11 zeros, 1. So it's a really small number, right? Actually, what they're trying to say is it's 0. Okay, so it's actually 4.12, comma 0. Don't write negative 1e, negative 12. You have to know that that actually is a very small number, which is very close to 0, and in this case it is 0. Okay, that's a tricky thing maybe about the calculator, is you might take its answers literally, and actually sometimes it's giving numbers that are very close to a number which is the real answer. Like it's giving answers that are very close to a real number or a whole number, and you actually need to give the whole number answers. Okay. The next, and like we could, remember, find the axis of symmetry by doing x equals negative b over 2a. In this case, what's b? B is negative 8 and a is 2. So actually negative b over 2a would be negative 8 divided by 2. Okay. Divided by 2 times 2 would be negative 8 divided by 2 times 2. Right? Negative b over 2a. So that would be equal to 8 divided by 4, which is equal to 2, and that's right. Okay? All right, let's do number 6. So you're saying, why do you even show us how to do it with x equals negative b over 2a if we can always find the vertex? Well, in these particular problems, you can always use the second calc min and second calc max to find the vertex, because that's how these problems are set up. But in other problems which you will have on the exam occasionally, you won't be able to do that. So we do need to understand how x equals negative b over 2a works, okay? All right, so we have now the equation 2x squared plus 6x minus 7. We're going to graph it, and then we're going to find the vertex. And wow, this vertex goes right off the screen, okay? And let's see what happens if we try to find the vertex and it's not even on the screen. So we do second calc minimum. We move the left bound slightly to the left of the vertex and we hit enter. We move the right bound slightly to the right and we hit enter. And then we do a guess. And oh, it's able to find the minimum even though the minimum is off the screen. Isn't that good? Okay, so there's some things it cannot do if it can't see them on the screen, but I guess vertex is not one of them. So the answer is negative 1.5, comma, negative 11.5. Okay, so what is our axis of symmetry? Well, our axis of symmetry has to be the x coordinate of the vertex. So it's x equals negative 1.5, right? What about the x-intercepts here? How do we find those? We do second calc 0, and then we move slightly to the left of the intersection point. We move slightly to the right of the intersection point, and we hit enter, and then we end up with negative 3.897. Do you see how the 7 will round the 9 up to 0? So it's actually negative 3.90, comma, 0. That is one of the x-intercepts. And the other x-intercept is this one. Let's find that using second calc 0 also. So we move the left boundary to here. We hit enter. We move slightly to the right. We hit enter. And then we hit guess, and we get 0.8979. The 9 rounds the 7 up to 8, so it's 0.898, comma 0. Okay, and that is it for 6. Let's do number 7. So 7 would be 0.5x squared minus x plus 2. Graph that. Okay, and then we're going to do second calc min again to find the vertex. These are all opening up, so we always use second calc min. Move the left boundary slightly to the left of the vertex. Move the right boundary slightly to the right of the vertex. Hit enter. We hit guess. And 0.9999 is actually 1, comma 1.5. So it's 1, comma 1.5 is the vertex. So we know that the axis of symmetry is the x-coordinate of the vertex, so it's x equals 1. Let's find the x-intercepts. We do second calc 0, and we move it slightly to the left. Oh, there are no x-intercepts. Do you see how it's floating above the x-axis? So there are no x-intercepts for this one. Okay, sometimes that's going to happen. What about number 8? Number 8, we're going to put 0.5x squared plus 3x minus 4. I'm going to graph it for fun. And then, ooh, there's the vertex again, second calc min. Oops, second calc min is what we're going to use to find the vertex. We move the left boundary slightly to the left of the vertex. We hit enter. We move the cursor slightly to the right of the vertex. We hit enter. And then we hit enter for guess. And we get -3, comma, -8.5. Do you see how instead of -3 it gave us -2.999999? Well, that's the same thing as -3. Okay, let's find, oh, the axis of symmetry would be the x-coordinate of the vertex would be x equals -3. And let's do the x-intercept here and here. We do that by doing second calc 0, and we move the left boundary slightly to the left of the intersection. We hit enter. We move it slightly to the right of the intersection. We hit enter, and we do a guess. It doesn't matter where, and the answer is -7.12, comma 0, and 1 times 10 to the -12 is the same thing as 0 in the calculator. And then we want to find this intersect too, so we do second calc 0 again, second calc 0 one more time. And then the left boundary is going to be anywhere to the left, so that would be here is fine. Hit enter, and then we move slightly to the right of the intersection. We hit enter, and then we hit guess anywhere, and it gives us 1.12, comma 0. Okay, so that's it for number 8. So now we have some exercises down here, which are going to find some other things. And I am going to continue that in a second.